Okay, so today we're going to be both simplifying algebraic expressions and comparing them. The comparing them is the new part. We did some simplifying last week by using zero to simplify things. So here they have two different expressions and they're asking which one is greater. So on the left, that's a negative 3. On the right, this is negative 2. So since negative 2 is greater than negative 3, the expression on the right is the greater one. So hopefully by now you have been able to build this one. And we're going to write the expression for each side. So for the left side, we've got x plus 2 minus 2 minus, and I always put this in parentheses even though you don't have to for this one, 3. For the right, we've got x plus 2 minus 3 minus 2 negatives, so minus negative 2. All right, so let's simplify this. What can we do over here on the left that would simplify things a good deal immediately? What can we get rid of that's equal to 0? Cadence? Yeah, these 4 unit tiles add up to 0, don't they? So on the left, we're left with x minus 3. And if we actually did this algebraically, 2 minus 2 is 0. So we're just left with x minus 3. Very good, thank you. On the right side, there are a couple of things that we can do to simplify that. What's one thing that we could do to simplify this? I'll take a volunteer. Yes.
Okay, so you could cancel those one tiles in the top, the 2 negative tiles and the 2 positive tiles.
Okay, so we could do exactly the same thing we did over there. We could cancel out all those, couldn't we?
Yeah.
Okay, good. There's one other thing that we could do. Quentin?
Wait. Yeah, you can cancel out the negative unit tile and one of the negative unit tiles in the opposite region.
Yeah, we can cancel out a negative tile in the positive region with a negative tile in the negative region. And then, if we wanted to simplify that further, right now it's x minus a negative 1. That's x plus 1. So which side of the expression comparison, Matt, is greater?
Right.
The right side, because they both have an x in them, right? And the x is the same for both. All right, let's go on to page 2. So, as Carl simplified some algebraic expressions, he recorded his work on the diagrams below. Explain what he did to each expression comparison mat on the left to get the one on the right. So what has he done on this one? Yeah, he has gotten rid of 0 pairs, right? So he eliminated we'll call them 0 pairs. Any pair that made 0, he just got rid of it. What about this one? How has he changed this from the original to the new one? Yes.
Since minus negative 1 is, minus negative 2 is the same as plus positive 2, he just flipped it.
Yeah. So here, he moved tiles from the negative region to the positive region, and flipped the tiles over. This last one is not something that we have done yet. But take a look at what he has done here. What has he changed from the original one to the new one? Yes, Jill.
Remove the X tile.
Yeah, and he removed one from the left and one from the right. Is that fair? Yeah. Now, has he changed the value? Yes, but he did it in a fair way so that they both lost the same amount. So here, he removed an X tile from both the left and the right. All right, so this is out of your book. Here are some ways to do legal moves. 2 out of the 3 we talked about just now. The third one we did not. So this is what they did in the first one. We can remove an equal number of opposite tiles that are in the same region. So here, these 2 make a 0, so we can get rid of them, right? Here, this is what we did in the second one. If you thank you. If you move something from the negative region to the positive region, you have to flip it over. It has changed signs, right? So this is another move that we can do. This last one is one that we talked about briefly when we were going over the homework. You can remove the same number of identical tiles from the positive and negative region. So that adds up to 0 also. Because if I moved these bottom ones up, what would they become? They would become positive, and I would have 2 positives and 2 negatives, so they're going to add up to 0. They cancel each other out. All right, let's go on to page 3. All right, so it says write an algebraic expression for each side of the expression comparison mats given below. Then use legal simplification moves to determine which expression on the expression comparison mat is greater. So we'll do left, and we'll do right. On this one, the way that it is a positive 1 minus 4 minus 1 minus 1 on the left. On the right, we've got negative 3 minus parentheses positive 3. All right, so let's move some of these out. I think moving like pairs in the same region out first is the best way to start. What are we left with on the left? Negative 3. On these, can we circle these and take them out? No, because they're opposite and in opposite regions. So let's bring these up and flip them over. What would that give you? Negative 6. Which one is larger? The left. Isabella, did you just send several scurrying? Your tiles. I think you accidentally knocked some off. All right. So let's write this the way that it is. On the left and on the right. On the left, we have a positive 1 minus 3 minus a negative x plus 4. On the right, we have x plus 2 minus 1 minus parentheses 3. All right, so we can take out this 0 pair. And then we can flip all of these over, can't we? That's going to be a little messy. So with the X tile, it's going to be colored in now. And all of these are going to be little negative tiles. So what are we left with? Pardon? What about the X? Okay. Or X minus 6? Either way is fine. Over here on the right, what can we take out? What, Nyla? Yeah, there's a 0 pair up here in the positive region. And then we can flip all these other ones over. Oh, we could have eliminated one of those before we flipped them over, couldn't we? Either way, after flipping them over, we still take this out. And over here, we've got x minus 2. So the x is the same. So we're comparing negative 6 with negative 2. So the right is the larger. I guess I should say greater not larger. All right, let's take a look at the next one. Isabella, what's one thing I can take out?
The two positive. Yes.
I'm sorry?
The you can take out the positive and the negative tiles.
Where? Which ones?
Oh, I'm looking at the wrong one. You could take out positive and the negative tiles both in the negative region.
Okay, so there's a positive and a negative that are both in the negative region. We can take that out. Yep. Let's back up just a second and let's write what this is to start with. On the left, we have y plus 2 minus 3 minus 2y plus 2 minus 1. On the right, we've got negative y minus 2 plus 1 minus 3 minus 2.
Minus 4.
Yeah, it's -4.
Oh, this should be 4 minus 2, not 3 minus 2. Thank you. Apparently I can do calculus, but I can't count. That's a problem. All right. What else can we take out, Warren?
On the right or the left?
Let's stay with the left.
We can take out two of the y's, the one in the positive and one in the negative.
Okay. We can take out this y and this y, for example, because that's a zero pair. Good. Alex, what's another thing we can take out? What are you looking at other people for? Ignore them. Okay, yes.
You can take out two of the zero pairs on the positive.
Okay, so we've got 2 zero pairs here, don't we? So we can take that out. All right, I think we've done all the taking out that we can do on the left side, but let's go ahead and write it. I'm not going to try to draw it because it's just too ugly and there's too little room, but what I'm going to flip this y up, so I'm going to have a negative y, and I'm going to flip this positive tile up, so I'll have 2 negatives. All right, Joshua, what's something I can take out on the right?
The zero pair in the top section.
Okay, so there's a zero pair in the positive region. Good. Rory, what's something else I can take out?
There's 2 zero pairs in the negative.
Yeah, there's 2 zero pairs in the negative region. I can take that one out, and I can take this one out. I think that's all the taking out that we can do. So let's see, we've got a negative y, and we're going to have a negative 1, but when we flip these two up, we'll have 2 more, so that'll be minus 3. So which one is greater? The left is greater. Yeah, they both have a negative y. So we're just comparing the negative 2 and the negative 3. All right, Sam, what's one thing I can take off on this one, on the left?
D,
I'm sorry?
D, right?
Yeah,
Okay. On the left,
yes.
you can simplify those two X's in the negative region.
Yeah, because one of them's positive and one of them's negative, so those are now gone. Good.
You can also flip the one in the bottom up to the top.
Okay,
Take it.
and that'll be now a positive one. Good.
Now you have
All right, well,
X.
hang on. Let me get some other people involved. Thank you, though. All right. Kiera, what's something I can do on the right?
You can take out the two X's.
Yep, you're exactly right. We can take out these two X's because they're the same sign but an opposite region. And that's the only thing we can take out on that one. Let's write the expression originally. So let's see, this one was x squared plus 3, and then minus, parentheses, x minus 1. And on the right side, I've got x plus 3 minus a negative x squared plus x minus 2. When we got done with the left side, we just had x squared plus 4. And again, just because it gets really messy on this one, if I flip all those over, we'll have an x squared, and we'll have 1, 2, 3, 4, 5 positive unit tiles. So the right is slightly greater. Please do the next one on your own. All right, let's see how you're doing. First of all, I'm going to write it. On the left, I've got x minus x plus 1 minus 3 minus 2y plus x. Just writing down exactly what I see. On the right, we've got a negative y and a negative 1 in the positive region, minus, in the negative region, a positive y, a positive x, and a positive 1. So let's start taking things out. Over here, there are 2 zero pairs that we can take out. A 0 pair there, and a 0 pair here. And then all this is going to get flipped into the positive region. So when I flip those 2 positive y's into the from the negative region to the positive region, that'll be negative 2y. And the same with the x, that'll be a negative x now. I've got minus 2. Over here, there is actually nothing that can be zeroed out, is there? But when I flip all these over, let's see what we've got. We'll have 2 negatives on the y's. We'll have a negative x. And we'll have minus 2, won't we? Did it turn out to be exactly the same? Yes. These are the same. We're going to skip F for now. Look on the last page real quickly. We've only got about another minute or so. So here, I could take those out. I could take these out. But notice on this one, I've got 3 x's on the left and only 1 x on the right. Am I ever going to be able to tell which one is bigger?
Yeah.
How? Do you know how big x is?
Never mind.
The problem is we don't know how big x is. Since we don't know how big x is, we have no way of telling which one is larger. All right, please make sure that your tiles are in the bag and just leave the expression comparison mat on the desk.
Don't you still have more X's on the left than
Yes.
We do have more x's on the left, yes.
because if X equals 15, you don't have 15 on one side and you have 45 on the other.
But I have more unit tiles on the right. So that's a problem, isn't it?